it's Mrs. Moret. I am here with your Unit 4 mid-unit assessment review, and we'll go ahead and get started. So on number 1, or station 1, mold population is changing by a factor of 1.2 every 30 minutes. Select all expressions that show the factor the population grows by in 20 minutes. So thinking about how much of 30 minutes is 20 minutes, and you can say, oh, it's 20 out of 30 or 2/3. And so 1.2 to the 2/3 is what we're looking for. And I see that right here. And thinking about, when we have a fraction exponent, that would be a root. The index of the root is 3, and the exponent is 2. So that's this option here. The rest of them don't meet that criteria for one reason or another. So just those 2. Part B, similar question. Circle the expressions that show the hourly decay factor for a population that decreases by a factor of 1/4 every 2 hours. So if it decreases by 1/4 every 2 hours, then the hourly decay, so just 1 hour is half of 2 hours, so we would take that factor of 1/4, raise it to the 1/2, and that looks like this option here. And then again, writing that in root form, the index of the root would be 2, the exponent would be 1, and that looks like this one here, the square root of 1/4. Okay, station 2, we have a function representing the population of the world in billions, T years since 2018. What was the world population in 2018? So that's going to be the initial amount right here. So 7.616 billion. I almost said trillion. And then in 2019, that would just be 1 year later. So the 7.616 times 1.011, I'm just going to go ahead and put to the first, 7.69976, or about 7 I would say maybe, about 7.7 billion. What is the growth factor per month? So T right here is in years. And so per month, there's 12 months in a year. So it would be 1.011 to the 1/12. 1 month out of the 12 months in a year. Leaving an answer like that is totally acceptable. Or you could approximate that on the calculator. Remember, if you've got that TI-83 calculator, you need to put parentheses around an exponent when it's a fraction. If you have the TI-84 and it raises the exponent up here, you don't need parentheses. So about, 1.00, I'm just going to round that up to 1.001. So about 1.001. And then per day, so there's 365 days in a year. So 1 day, 1.011 to the 1/365. Again, you could leave your answer like that. 1/365. So I would want to maybe leave my answer like this. There's 4 zeros before we would round that 2 up to a 3. So either way is fine. All right. The second question on station 2, Account A doubles every 2 years. Account B triples every 3 years. What is the yearly growth factor for each account? So yearly, meaning 1 year. So for account A, I would say doubles every 2 years. In 1 year, it would be 2 to the 1/2. And then account B, if it triples every 3 years, then tripling every 3 years in 1 year, 3 to the 1/3, 1 out of those 3 years. And then again, we can type into the calculator 2 to the 1/2, about 1.41, 3 to the 1/3, about 1.44. So it looks like account B has a larger yearly growth factor. So it's going to be growing faster. All right, station 3. So algae in a pond is doubling every 8 days. The initial study showed an algae population of 20,000. Write an equation to describe the population of algae D days after it was measured. So it doubles every 8 days. So I'm going to say, let's see here. I'm going to say A for algae. It doesn't give me a variable. The initial amount, 20,000. It's doubling every 8 days. So it takes 8 days before it can double. So I have to divide the number of days by 8. A colony of 100 bacteria is doubling every 6 hours. 100 bacteria doubling every 6 hours. Write an equation to describe the colony's population H hours after it was first measured. Again, I'll use P for population. It doesn't say what to use, so I can decide. I'm going to write mine a little bit differently this time. I'm going to write this in terms of the daily growth rate would be 2 to the 1/2 because every day, 2 to the 1/6, it doubles every 6 hours. So the hourly rate, oh my goodness, would be 2 to the 1/6. This is the hourly rate, and I'm just going to raise that to the H. So we kind of have 2 different ways that you can write that equation. Either one's totally acceptable. So I'm just going to write out the first one. You could also write this as A equals 20,000 times 2 to the 1/8 to the D. And then we could write this the same way I wrote A the first time. 100 times 2 to the H over 6. Okay, so both answers are totally great answers for those problems. All right, or. Okay, next, caffeine has a half-life of approximately 6 hours. How much of the caffeine in a cup of coffee will remain 6 hours after consumption? Well, if the half-life is 6 hours, then 6 hours after consumption, we would assume there would be half of the coffee or the caffeine remaining. Or you could say 0.5, or you could say 50%, any of those, okay? Now, 2 hours. So in 2 hours, we're going to use a fraction exponent. It's 2 out of the 6. Okay, that answer would be totally fine. If you wanted to put it into a calculator, a 1/2 to the 2/6 is about 0.794. If you wanted to write that as a percent, 79.4%. All 3 answers are equally awesome. And finally, after 1 hour, 1/2 to the 1/6. And you might go, oh, that's going to be half of this. Is it? Let's see. 1/2 to the 1/6 is 0.891-ish. Okay, so 0.891. So definitely not half of that. And then as a percent, 89.1%. All right. Okay, so the other question here in Station 4, similar question. An investment account grows by a factor of 1.3 every 4 months. 1.3 every 4 months. By what factor does it grow in 1 month? So in 1 month, 1.3 to the 1/4. And I'm just going to leave these answers as that, okay? In 3 months, 3 out of the 4 months. So 1.3 to the 3/4. And then finally in a year, well, a year is 12 months. So 1.3 to the 12/4, or you could just say 1.3 to the 3rd. All right. So again, you could totally put that into a calculator, but those answers are totally acceptable, and we're done with page 1. So a couple more on the second page, or the back side for you guys. All right, so we have some exponential graphs, and we need to write some equations. Remember that we have to use the information that we have here, but eventually our final equation needs to have our B value, that growth rate, be showing an increase of 1 in the independent variable. So usually in the time interval. So intervals of 1 on the x-axis. So I need to figure out, I can use this information from 0 to 5 by dividing 96 by 3. And I can get a growth factor for 5 intervals, but then I need to change that, work on it a little bit so I know the growth factor for just an interval of 1. All right, so from 0 to 5, I'm going to first say, oh, well, that's going to be 96 divided by 3. And 96 divided by 3 is 32. Okay, so it's a factor of 32. An interval of 1 is 1/5 of this entire interval, right? So now I have to say, okay, B is equal to 32 to the 1/5. And 32 to the 1/5, I know it's 2. See that? 32 to the 1/5 is equal to 2, because 2 to the 5th is 32. So this is just doubling, okay? So for our function f of x, the starting amount is 3. I know that because that's the y-intercept. The growth factor in one interval is 2 to the x. All right. I'm going to use a similar method in part B. And I'm looking at going from a 0 for the x to a 1.5. Okay. So same strategy. I'm going to start by dividing 71.68 by the term before, 140. That's going to be in an interval of 1.5. And so 71.68 divided by 140 is this decimal, 0.512. I'm going to use all the places because that will give me the most accurate answer when I'm finished, 0.512. Okay, so when I think about, well, an interval of 1, so I need the interval to be from 0 to 1. I currently have 0 to 1.5. See how I can split that up into 3 equal intervals? From 0 to 1 is 2 of those 3 intervals. Okay, from 0 to 1 is 2 of these 3 intervals. And so that tells me that B is equal to 0.512 to the 2/3. Okay, 0.512 to the 2/3 is equal to 0.64. And so I'm ready to start writing the equation. I can see the initial amount is 140 since that's the y-intercept. And so f of x equals 140 times 0.64 to the x. All right, we are at the last question. The graph shows the amount of medicine in a dog's body 8 hours after an injection. By what factor did the medicine decrease in the first 1.5 hours? We actually have that data on the graph. And so we're going to divide 270 by 640. And that gives us 270 divided by 640 gives us this decimal. Now, I know it's kind of big, but I'm actually going to write out the whole thing because, again, it makes it the most accurate further down the road. So this is 0.42875. Oh, and I know I showed you guys this in class the other day. We could also see, well, what is that as a fraction? So math followed by enter and enter again. Oh, it's 27/64. I'm going to write them both. So that was just math, the math button right here, and then enter, enter. Okay, by what factor did the medicine decrease in the first 30 minutes? So in the first 30 minutes, that would be like a half an hour, right? Again, if we think of this this is an interval of 1.5 from 0 to 1.5. The first 30 minutes is 1/3, one out of these three that make up this whole interval. So if I know this factor, I can say, oh, I'm going to use the fraction. In the first 30 minutes, it would be the factor for the entire interval to 1.5, but raised to the 1/3 because it's only one out of those three intervals to get all the way from here to here. So in the first hour, I can use that same idea. It's going to be, oh, sorry, I just was thinking about something. I can go ahead and do that 27/64. 27/64 to the 2/3. And then that is exactly 0.5625. Or you could put it into a fraction. It's 9/16. Okay. So from here, you have some options. By what factor did the medicine decrease in the first hour? Well, I could use this factor and say that represents this one interval. So I would raise it to the second power to get the entire interval for the first hour. Or I could use this factor and raise it to the 2/3 because from 0 to 1 is 2/3 of the way from 0 to 1.5. Okay, so two ideas. One is to take the 9/16 from the 30-minute interval and raise it to the second to get an entire hour. The other is to take the 27/64 from the 1.5 interval and raise it to the 2/3 to get just the hour. So let's look at them both. Okay, so the first one, 9/16 squared, and the other one, 27/64 to the 2/3. Oopsies. What did I do wrong? Oh, I think it's up here actually. 27. It's right here. I did 27/64 to the 2/3. I got to back up. Oh, and it's the end of the video. So I'm just going to redo this one problem. Shoot. So this to the 1/3, I just typed it into my calculator incorrectly. You maybe even caught that. So I'll just do it again. I don't want to redo the entire video. 27/64 to the 1/3 is 0.75. And then that as a fraction is 3/4. Which means that down here, I should be able to square 3/4. Okay, I should be able to square 3/4 and get the same thing as 27/64 to the 2/3. So let's give this one a try. My goodness, I'm so nervous. Oh, phew, that's the same answer. So 0.5625 as a fraction, it's just going to be 9/16. And you can see this one, 27 divided by 64 to the 2/3. Again, you can write a decimal, 0.5625. As a fraction, it's just 9/16. Okay, so I just gave you two different ways to get to the answer. You only have to find one. So the hourly decay rate is 9/16. Now we can write an equation. So the equation relating M, the number of milligrams of the drug in the dog's body, each hour since the injection. So M equals that initial 640 milligrams times 9/16 to the H. All right, that is the end of your review and video help. Sorry about the snafu on the last part, but you know what? We figured it out and it's all good. So best of luck on your test on Monday. And yeah, you're going to knock it out of the park.